now we can begin our lesson. Right. Right there. Right. So this is the problem that I sent you guys. So the video I sent you was based on this problem. Right. And we went on that video. I went as far as calculating what is this, theta. Right. In fact, I went as far as calculating the included angle. Right. I would assume that you guys have no questions regarding how we got to having determined the included angle. Right. If you went through the video, I would expect that you understand how we got to this point. Am I correct in this assumption?
Yes, sir.
Are there any questions pertaining to how we get to this step? No questions. All right, wonderful. Right. So at the moment, we've went up to calculating the angle theta. Right. So now we are going to calculate our other unknowns. Right. Our other unknowns being the value of y as well as the value of x. Right. I'm going to show you how we go about getting those measurements. Right. Now, first, we are going to calculate the value of y. Right. The reason for that is because once we've calculated y, it's going to be easier to calculate x than to first calculate x and then calculate y. All right. Now, just so we are clear, right, for these kind of problems, right, you must always draw this triangle. I think I also covered that in the video. That for these kind of problems, if you're looking at taper plugs, right, you should always draw this triangle. And once you've drawn this triangle, the angle that you have here will always be equal to theta. All right. If you haven't watched the video, right, you must first watch that first lesson. Right. And then, of course, once I've uploaded this lesson, watch this lesson thereafter. Are we clear? Hello?
Yes, sir.
Right. Right. So now we are going to calculate x and y. First, we are going to calculate the value of y. Right. The way we are going to calculate the value of y is we look at which algebraic expression it is a part of, right? If you look at the value of y, right, y is a measurement from here to there, right? So meaning y essentially is a part of the algebraic expression of 84,38, right? 84,38 is from here to there, right? So when I say y is a part of the algebraic expression of 84,38, right? It is based on the fact that if 84,38 is essentially from B to G, it means essentially BG is equal to BC plus BD plus Y plus EF plus FG, right? So Y is a part of the algebraic expression of 84,38 from that perspective, right? Right. So let us first write that down, right? We have 84, was it 38? 84,38, yes. So what is the algebraic expression of 84,38? The algebraic expression of 84,38 is BC plus BD plus Y plus EF plus FG, right? So essentially, this is what you have. The algebraic expression of 84,38 is BC plus CD plus, so DE is essentially equal to Y, so we'll just write Y here. So CD plus Y plus EF, right? EF plus FG, right? So this is the algebraic expression of 84, 84,38. So 84,38 is equal to this here. Are we in agreement here? Do you guys see
Yes, sir.
how I got this algebraic expression?
Yes, sir. Yes, sir.
Right. Now, you must take note of a few things here, right? If you look at BC, right, what would you say BC is equal to, right, in conjunction with this roller here?
Radius.
Right. So if you look at BC, BC is equal to the radius of the roller, right? So we've been given the diameter of the roller, right? It's 20 millimeters, right? Meaning that if this is equal to the radius, it means this is equal to 10 millimeters, right? Now, if you look at the huge triangle, right? Remember, we split it in half, right? And then at that point, the half on the left of the triangle and the half, the triangle on the right hand side are exactly equal, right? So meaning that even when looking at seeing that the rollers are also have the same diameter, right? It means that the distance or the measurement CD, right, is going to be equal to what? The measurement of EF, right? So CD here is equal to EF, right? And what can you say about FG here? What is FG going to be equal to?
BC.
Equal to BC, meaning that it is equal to the radius, right? So essentially, BC is equal to FG, both are equal to the radius, right? And CD is equal to EF, right? Now, we have the radius, so we can get BC as well as FG, but we don't necessarily have the measurement of CD and EF. But seeing that CD is equal to EF, we'll be able to express one in terms of the other so as to eliminate one unknown, right? So that is to say, from this algebraic expression, we can express this as this is equal to BC is equal to the radius. The radius is 10. So this is 10 plus, we call this CD, plus Y, plus, we've established that EF is equal to CD. So seeing that EF and CD are equal, we are going to express EF in terms of CD. That way we eliminate EF as an unknown, plus FG. FG is equal to the radius. The radius is equal to 10. Right, so essentially what you have is 84,38 is equal to, so this becomes 20 plus 2CD plus Y, right? So that is to say, in order to get Y, we have to determine CD, right? So from this algebraic expression, if we want to get Y, we first have to calculate CD, right? Are we together?
Yes, sir.
Right. So how do you calculate CD? Right. The way we calculate CD is, now remember I said if you have two tangents meeting at a common point, then those two tangents are said to be congruent, right? Now if you look at this tangent, right, it is meeting this tangent at this common point, right? This is a tangent, it is touching those two rollers once, and this is the tangent because it touches this roller once as well. So you have this tangent as well as this tangent meeting at this common point. Hence, the two tangents are said to be congruent, right? Such that if you were to split the two tangents into two equal halves, right, the angle you get on this side will be exactly equal to the angle you get on that side, which is exactly what we did in determining theta here, or rather the included angle. Do you remember this?
Yes, sir.
Right. So that is to say, in order for us to be able to split the two tangents, right, equally, what you do is you draw a line from the center of this roller, right, to where the two tangents meet, right? So you draw a line from the center of the roller to where the two tangents meet, right? When you do that, what you've done is you've equally split the two tangents, right? So you split this tangent and this tangent into two equal halves, meaning that this angle, right, is now exactly equal to this angle, right? And as such, it means this whole angle, right, is twice this angle or twice that angle, right? So that is to say, this angle here is essentially half of this angle. So if you can get this whole angle, you will inadvertently get this angle because, as we've established, this angle here is half of that one. Are we clear here?
Yes, I'm clear, sir.
Now, why am I talking to one person in here?
It seems like it's only me, sir.
Where's everyone else?
I don't know. They online, but there's nobody speaking.
No, we're listening, sir. We're listening. Don't worry.
Yeah, we can hear you, sir. We can hear you.
But you can say I mustn't worry. I should know if you guys are with me or not.
Right, we are with you, sir.
Yeah. So if I'm asking if you guys are with me, I expect a response. We good?
We're good.
All right. Okay. Now, as we've established that this angle is half of this whole angle. Now, what is this whole angle equal to? That's not a rhetorical question. What is this angle? What is this angle equal to? By looking at our diagram here, what is this angle equal to? So I'm asking for this whole angle. What is this whole angle equal to? Come on, people. Right? If this angle is equal to beta, right, can't we see that these two angles are alternating?
Yes.
Right? This angle alternates with this one.
No.
Can we see that?
Yes.
Right? Meaning that if this is beta, it means that's beta as well. Right? Now, that is just one way of looking at it, right? Someone else could have looked at it from this perspective, right? If you look at this line and this line, right? This is perpendicular to that. So meaning this angle is 90 degrees, right? So if this here is theta, it means this angle is going to be equal to what? 90 minus theta. And 90 minus theta is equal to what? Is equal to beta. Can we see that?
Yes.
Right. So you can look
Yes,
at
sir.
this in whatever perspective you look at this, right? You will end up with this angle being equal to beta, right? You can either say you have alternating angles, hence this is beta, or you can look at the fact that this angle is 90 degrees. And since we've established that this here is theta, it means this one will be 90 minus theta. 90 minus theta gives us beta, right? If you look at this triangle, this right angle triangle, right? If that's theta and that's 90, it means this angle is 90 minus theta, right? Meaning that if you have 90 minus theta anywhere on this taper plug, right, 90 minus theta will be equal to what? Will be equal to beta. Are we clear here?
Yes, I'm clear.
Yes, sir.
Right. Let's make this that color. Right. Now, so as we've established, right, this whole angle is equal to beta. So if this is equal to beta, that being half of this angle means that this small angle here will be half of beta. All right. So let us calculate that angle. All right. Before we do, remember I said to equally split the two tangents into two equal halves. What we do is we draw a line from the center of this roller to where the two tangents meet. Now, when you do that, you inadvertently get this right-angled triangle. This one here. Do we see that?
Yes, I
Yes,
see
sir.
it.
Right. So once you have that right angle triangle, right, if you have an unknown in a triangle, right, you need two knowns, right? Those two knowns can either be in a form of an angle, of two angles, or two sides, or one side and one angle, right? So at this point, because it seems we'll be able to work out this angle, it means this angle will be a known, and we know this side, right? What is this side equal to, right? From here to there, what is that equal to?
10.
Say again.
10 millimeters.
10.
10, right? So this here is the radius, right? So on this triangle, we have one unknown, which is CD. One unknown on the triangle requires two knowns. Those two knowns for this triangle would be this side, which is equal to the radius, as well as this angle, right? So we are going to calculate this angle. This side we've already established is equal to the radius, hence equal to 10. And then we'll be able to calculate CD using, what is this? Using trig ratios, right? So let's calculate this angle, angle D, right? So angle D, also we say, so in this case, because we are calculating an angle, right? We have to specify the triangle that we are looking at, right? So we are going to name this point. Let's say we are going to name this point M, right? So we're going to call this triangle CDM, right? And say in triangle CDM, right, angle D, right, is equal to, we have already established that angle D is equal to half of beta. So this will be beta divided by 2, right? Now, what is beta equal to? We also established that beta is equal to 90 minus theta, right? From this triangle, right, from this triangle, right, this triangle. Okay, this thing doesn't want to do this. So let's say, right, let's just do this. There we go. Right. Now, the triangle that I've just highlighted, right? From the triangle, right, we can establish that this angle is equal to what? 90 minus theta, right? So that's beta, right? So essentially, beta is equal to 90 minus theta. So this will be 90 minus theta, and theta is equal to 4,818. So this is minus 4,818, right? Divided by 2. And what do we get here? What is this equal to? Let's go, people. Hello, what is this equal to?
I'm just fixing my calculator so quickly.
42.593.
So 42,
593.
593 degrees, right? So that's the value of angle D, right? So from triangle CDM, right, we are looking for CD, which is the one known. We need two knowns, which is the radius and this angle, so we can get CD, right? So still on that triangle, to get CD, we then use trig ratios, right? So because you're looking for the side that is adjacent to the angle, the side we have is opposite the angle, right? So which trig ratio is convenient for us to use here? You have SAW, CA, TOA, right? Which of these trig ratios is convenient for us to use based on what we've been given?
10.
10, right? Tan is the one that is convenient for us to use, right? So we say the tan of D, the tan of angle D, right, is equal to tan is opposite divided by adjacent. The side opposite is the radius. So that's going to be the radius divided by the adjacent side, which is CD, right? Now from this, we are looking for CD. So we make CD the subject. Making CD the subject, this will be equal to the radius divided by 10 angle D, right? The radius is equal to 10. So this divided by the tan of angle 42,593. And what is this equal to?
Ten, 877.
10,877. So this is in millimeters. Right? Are we getting the same thing?
Yes, then
Yes, sir.
I'm gonna run off most to 3, so it's gonna be 878.
So it's supposed to be 878.
878, yes, sir. If we are gonna round off to 3 decimal places.
Right? Always round off to 3 decimal places. Right? Always. Are we clear here?
Yes.
Right. So we have the value of CD. So once you have the value of CD, from this algebraic expression, we'll then only have one unknown, right? That unknown being y, we then solve for y here. Right? So solving for y, right? Solving for y, we know this is the algebraic expression of 84,38, right? So solving for y or making y our subject, y is going to be equal to the 84,38, right? When you transpose this term, it becomes negative this side. You transpose this term, it becomes negative that side. So this is minus 20 minus 2 into CD. CD, as we've established, is equal to 10,878, right? And then what is going to be the value of y? There must be something to calculate. What did you get?
I'm getting, say, yeah, by me 60,624.
Okay, so this is 84,38 minus 20 minus 2 into 10,878. So that is, so I'm getting 42,624. Yes, millimeters.
Correct.
Right? So that then becomes the value of y. Right? That's how you calculate that measurement. Right? Any questions here?
No, I'm all good. That is the similar one that you explained on the YouTube video.
Sorry?
That calculation that you explained about CMD, it's the same one that you explained on your YouTube video.
Oh, okay.
The one that you said you must go through.
Okay. Right. So now to calculate x, right? Once you have the value of y, calculating x, right, becomes a walk in the park, right? If you look at x, right, you look at which algebraic expression x is a part of, right? X is from here to there. So essentially x is equal to that measurement plus this measurement. Now this measurement in particular, right? If you project this measurement, right, to down here, you see that this measurement is exactly equal to what? Equal to y, right? So this measurement plus essentially y plus that measurement will give you X, right? And then, of course, this side being exactly equal to that side means that this measurement is equal to which one? Is equal to that measurement, right? So if we were to name, say, name this N, call this O, right? Now, if this is NO, right, the measurement of NO is exactly equal to this measurement. So this you can name NO as well, because as we've established, this measurement is exactly equal to that one. Right, so if you can get this measurement eventually, right, if you can get this measurement, right, then you'll be able to get X, because we've established that this is equal to that, and we know ON, right? So this measurement we know is equal to what? Is equal to Y. Right, so we are going to calculate this measurement NO, right, using this triangle, right? Now, as we know by now, right, on a triangle, if you have one unknown, to determine that unknown, you need two knowns, right? Of which we know this angle, right? We know the angle theta, right? We are looking for this side. We also know this side, right? This side OD is equal to, we are given that from here to there is 20 plus 95,74, right? And then we also have to account for this here. Now, what is this measurement equal to?
That measurement is 10.
Right, this measurement is equal to the radius, right? If you look at this line, from here to there is equal to what? The radius, right? So essentially OD is equal to the 20 plus 95,74 plus the radius. That gives us this side. So to get this, we needed two knowns. We have two knowns. We have this side as well as that angle theta. So we can get this side, right? So now we can say in triangle DON, right, you can say in triangle DON, right, triangle DON, what we have here is this. Right, that's N, that's O, that's D, right? Now we said this angle is equal to theta, which we've calculated, and then OD we established is equal to 20 plus the 95, what is this equal to? 95,74, right? So this is 95,74 plus the radius, which is 10, right? Now what is this equal to? All right, so you have 95,74 plus 30. So this is actually equal to 125,74 millimeters, right? So we have that side. Now we can calculate NO, right? We have this angle, right? The side we have is adjacent to the angle. The side we're looking for is opposite the angle. So which trig ratio is convenient for us to use here?
10 again.
10. So we use the tan of theta being equal to the side opposite. So NO divided by the side adjacent, which is OD. So we are looking for NO. So you cross multiply, solving or making NO your subject. So this becomes OD times tan theta, right? OD we've established is equal to 125,74. So this times tan theta. Theta is 4, what is theta equal to? 4,814. So this is 4,814, right? And we get this measurement, right? So it's 125,74 tan 4,814. So I'm getting here 10, so this will become 10,590 millimeters. Right? Are you getting the same thing here?
Yes, sir.
Yes, correct.
Right. So NO is 10,590, Right. Once we've determined that measurement, right? So now we know what this measurement is. That means we inadvertently know what this measurement is. So we are able to get X because we also know what this measurement is, right? So to get X, right? To get X, the algebraic expression of X is equal to essentially 2 times NO plus Y, right? That's the algebraic expression of X. So now to calculate X, we simply say X is equal to 2 times NO times Y. Now you simply substitute. 2 into NO is 10,590, and the value of Y is 42,624. So this is 42,624, right? And this gives us the value of X. So essentially X is equal to 53,214 millimeters, right? Are we getting the same thing?
So, anything.
Right? So that is the approach you would take for such a problem.
So can we please go back to that answer again?
Which answer?
The last one. It's supposed to be
53,214.
63. It's supposed to be 63.
63,804.
63.
Yeah, 63,804.
Right, because we said 2 times 10.
Yes.
So this becomes 63,804. So this is 63,804 millimeters. Yes, that is correct. 63,804. Right, and that is the approach we take, right, for such problems. Right, you simply look at what it is that you're looking for, right, and see where you can create triangles, right, to either get an angle or get a side of that angle. I mean the side of that triangle, right?
So with the statement that you just said, can I please just ask a question? How do we know where to put that triangle and where do we start up? Because I think that's where the problem is with these triangles.
Okay, so did you watch the first video?
Yes, I watched all the videos. Yes.
So in the first video, I think I mentioned that this triangle, right? If you're looking at a taper, right? If you're looking at a taper plug, so a taper plug would look like this one, right? For a taper plug, you will always make use of this triangle. So meaning, if you come across a problem based on taper plugs, right? The first thing you would do is draw this triangle, right? Between this center and this center.
Okay. Okay, thank you.
Right? Regardless of what it is that they are looking for, right? This triangle will always come in handy. Right? I think I even mentioned in the video that you will never have to prove that this angle is equal to theta as such, right? But I only proved it to you so that you don't have any questions as to how did we arrive to this being equal to theta, right? But saying that, we've established that this angle will always be equal to theta, right? If you come across a problem based on taper plugs, first thing you do is draw this right angle triangle, right, between this center of this roller and this center of this roller, right, and then work from there. Right, and then also, if you look at these two, right, if you look at this measurement as well as that, as well as this measurement, right, those two measurements will always be equal. Right, and the way you get this measurement is by drawing a line from the center of the roller to where this tangent and this tangent meet. Right, this thing is tailor-made for you. Are we clear?
Thank you very much. I got it now.
Right, any more questions?
So one question from my side is on your answer sheet, to all the the triangles like on the paper plot itself. You have to copy the triangles like, to explain it from.
Right. So on the answer sheet, all you need to do really is to roughly draw this here, right? Roughly draw the diagram and show any and all triangles that you will be using on the one diagram.
Okay.
Right.
Okay.
Just like how I did here. Just like how I did here. That's exactly how you do it. Right. That way,
okay.
when you write your solutions, right, instead of drawing triangles, you can just say in triangle so and so. Right. That way your marker is able to refer to the triangle that you are talking about.
Okay, so yeah, so that you can identify where you get your,
Yes.
say your triangles or something like that. Okay.
Yes.
That's good with me. Thank you.
Right. Drawing the diagram is helpful from the sense of just in case you guys make a mistake here, right? The marker is able to identify you only made a mistake for maybe this one, right? But when you got here, right, you used that mistake correctly. That way you don't have to lose the marks for all the problem, but you can just lose marks for having calculated this wrongly, right? But I can only do that if you've given me context. How you give me context is by doing this here, saying in triangle so and so. Are we clear?
Yes, this is very clear to me. Thank you, sir.
Right. Now, just so we are clear, this doesn't have to be right to scale. Right. It just needs to be appropriate. Right. It doesn't necessarily have to look nice. Right. But make it very clear and do all your labels on the one diagram. And then when you do your calculations, you simply say in triangle so and so, right? Or for measurement so and so. Are we clear here?
Yes, that's very clear. I think what I can do is if I draw the diagram in pencil, then I can just take my blue pen and just mark or do the triangles that I'm doing just to show where the triangle is. Just with the blue pen.
Yeah, that's fine as well.
Okay. Thank you, sir.
So I have a question.
Yes.
In triangle MDC, how do we calculate the angle of angle D?
Angle D.
Yep, by the smaller
Right.
triangle.
Right. So what we did was we first established, right. In fact, what we did was we first took note of the fact that you have these two tangents. So this tangent, right, and this tangent. Do we see that? Do you see those two tangents?
Yep.
Right. This tangent and this tangent are meeting each other at this common point here. Right. So that is to say the two tangents are congruent. Right. So meaning if you are able to split them into two equal halves, the angle you get on either side are going to be equal. Now the way you split the two congruent tangents is by drawing a line from the center of this roller to where the tangents meet.
Mm-hmm.
When you do that, you've equally split the two tangents such that this here, this angle is equal to that angle, right? So that is to say this whole angle now, right? This whole angle is this angle plus that angle, right? So to get this one, you first establish what is this whole angle, right? To get this whole angle, we then establish that you have this angle alternating with this one. Do you see that? So essentially, this angle alternates with this one, meaning if this is beta, then that's beta as well.
So angle D will be half of angle B in a way.
Say again?
So in triangle MDC, you can say that angle D will be half the value of angle B.
Yes. That's exactly what I'm saying.
Got it, sir.
Yes. Any more questions?
and if you use angle of
I can't hear a thing, my guy.
CD, the triangle, the D, all right, you can see 90 degree minus
Chief, we can't hear you. There is a lot of breakage where you are. Can you perhaps try again?
My signal is very poor, sir, so it's fine. I already have the answer. It's fine.
Okay. Any more questions?
Yes, sir. Sir, I see we have there by that picture, sir, where on that angle 90 there by that picture, so we have a 90 mustard whole angle.
You mean here?
So I see here we have, yes. Come again, sir?
You mean here?
Yes, yes, sir. There we have in that when we substitute there by picture, we put 90 minus 4,814. Then I just want to know where is that 4.814 coming from?
Remember in the first video, right, we calculated theta, right? The 4,818 is the theta. Or are you saying
Yes,
we
sir.
used
Okay.
the wrong value here? Where's this thing?
No,
Oh,
not
yeah, we
exactly
did
that.
the wrong value. So this was supposed to be 8,818. Right? This was supposed to be 8,818. So that's obviously going to change our answer slightly. Right? So the 4,818 is the value of theta, the one we calculated, right, in the first lesson, the angle of theta. Right? So this theta, right, this theta, right, this theta is equal to 4,818.
Yes, sir. Thank you, sir. I see now, sir.
Okay, cool. Any more questions? Right. I've just noticed here that we use the wrong value for theta here. Right. I don't know if you saw, but I had 4,814 as opposed to 4,818. Right. So maybe let us redo this quickly. So this is going to be 125,74 tan 4,818. So this now becomes, so this is going to be 598. So 598 millimeters, right? Meaning also this is going to be different. So this is now 598, right? So 2 times 10,598 plus the 42,624. So this becomes 63,82. Right, 63,82 millimeters. Right, so if we use the correct angle here, right, this is what you get. Right, I will be setting this in the group. Any more questions?
I'm good.
So no more questions. Right.
I'm fine also, sir, my side.
Okay, beautiful. Now, the videos I sent yesterday, are you guys still watching them? Are you done watching them?
I just need to watch only one and then I'm done. All the videos.
Okay. So I'll give you some time to finish watching those 2 videos, right? And then I'll address questions, right? So in our next live session, I'm going to address questions pertaining to the 2 videos, right? And then we'll look at maybe 2 more examples, 2 more exercises, and then we'll be done with precision measurement. Right, with precision measurements, if you're comfortable with doing taper plugs, right, you'll be comfortable with doing any problems based on precision. Right? There is no particular principle that you need to be familiar with. Right? This is simply mathematics, if you think about it. Right? It's unlike the likes of dynamics, where you have to be familiar with a bunch of principles, right? Engineering principles. With precision, it's just maths. Are we clear here?
Yes, we're clear, sir.
Yes, sir.
Right? Right. So finish those 2 videos, right? And then in our next session, we will go through any questions if you have questions, right? And then we look at 2 or 3 more exercises, and then we can move on from what is this thing? We can move on from precision measurement, right? On Sunday, right? Either on Sunday or tomorrow morning, right? I will be sending you my playlist on hydraulics, so that you can start, so that those that are comfortable with precision measurement can start watching that. Are we clear here?
Yeah, excellent.
Okay, beautiful. If there is nothing else, we can end our session here.
Okay, thank you for the session, sir.
All right, cool, man.
Thank you,
Yeah.
sir.
Thank you, sir. Thank you.
All right, cheers.
Danko, Danko.